So today what we're going to be working on is simplifying square roots with variables. So I'd like you to do the try this, which is simplifying these square roots. So put me on pause and then come back and check your answers. Okay, so for the first one we have 6 to the square root of 45. So the largest perfect square that goes into 45 is 9. So bring down the 6. So we have 6 times the square root of 9 times the square root of 5. 6 times the square root of 9 is 3, the square root of 5, and 6 times 3 is 18, so it would be 18 the square root of 5. Okay, number 2, we have, I'm just going to write this over here because I don't think I gave myself enough room here. So we have negative 3/4, the square root of 80, so bring down the negative 3/4. Find the largest perfect square that goes into 80. That would be 16 times 5. So we have negative 3/4. The square root of 16 is 4, the square root of 5. And then 3/4 times 4 is negative 3, the square root of 5. All right, so now let's talk about perfect squares that are variables. Okay, so remember, a perfect square comes from multiplying a number by itself. So let's start with x times x. All right, so we have x times x is x squared. Remember, you add the exponents. X squared times x squared is x to the 4th. X to the 3rd times x to the 3rd is x to the 6th. X to the 4th times x to the 4th is x to the 8th. Hopefully you are starting to see a pattern. X to the 5th times x to the 5th is x to the 10th. So what do you notice about all the exponents? All the exponents here, just look at them. We have 2, 4, 6, 8, 10. All the exponents are even. So the next one would be x to the 12th. And then we would have x to the 14th. If we keep going, we would have like x to the 30th, x to the 50th. Anything with an even exponent is a perfect square for a variable. All right, so now let's write down their square roots. So the square root of x squared is x. The square root of x to the 4th is x squared. The square root of x to the 6th is x to the 3rd. The square root of x to the 8th is x to the 4th. The square root of x to the 10th is x to the 5th. So notice, what do you notice about the exponents? Remember, this exponent right here is actually a 1 when there's no exponent written. So what do you notice about the perfect square and the square root exponent? The perfect square exponent and the square root exponent. Hopefully you notice that when you take the square root of all these even exponents here, it's half the exponent. So if I wanted to do the square root of, let's say, x to the 24th, I know it's x to the 12th. If I wanted to do the square root of x to the 30th, that's x to the 15th. Okay, so it's always half the exponent. All right, so now let's actually start simplifying. All right, so when we simplify, it's really the same way as numbers. You're going to find the largest perfect square that divides into the radicand evenly. Remember, that's the number that's under the radical. Now remember, variables, when we have variables, have even exponents in order for it to be a perfect square. If the exponent is odd, then your perfect square will be 1 less than the exponent, which kind of makes sense because if your exponent is, let's say, 7, go down 1, x to the 6, that would be a perfect square. You're going to make a factor tree. Now I would put all your perfect squares on the left and your non-perfect squares on the right. You're going to take the square root of all your perfect squares and then keep the radical in the radicand. All right, so let's take a look at the first one. So we have the square root of x to the 3rd. Alright, so I'm going to make my factor tree. So notice my exponent is odd, so I go one less than that. So it's x to the second. Notice x to the second, even exponent. So I know it's a perfect square. The square root of x to the second, do half the exponent, you get x. So it's x and then the square root of x. Alright, let's try number 2. X to the fifth, the square root of x to the fifth, and y squared. So make a factor tree. So I have x to the fifth here. It's one less than that, so it's going to be x to the fourth. X to the fourth times x is x to the fifth. Y squared is a perfect square, so I'm going to put it onto the left side. The square root of x to the fourth is x to the second. And the square root of y squared is just y. And then you bring this down. So my answer is x squared y, the square root of x. All right, let's take a look at number 3. We have the square root of 32 x to the 7th. So what perfect square goes into x to 32? That would be 16 times 2. The perfect square that goes into x to the 7th, go one less than 7, would be x to the 6th times x. The square root of 16 is 4. The square root of x to the 6th is x to the 3rd. And then we have the square root of 2x. And then we'll try number 4 here. All right, so I have that negative 2. I'm just going to carry that negative 2 down. Okay, what perfect square, we're going to start with the 50, goes into 50? That's 25 times 2. A to the 3rd, go one less than that, that's a squared times a. B to the 9th, go one less than that, that's b to the 8th times b. C to the 10th is a perfect square, so we'll put it over here. C to the 10th has an even exponent already. All right, so we bring down the negative 2 here. The square root of 25 is 5. The square root of a squared is a, half the exponent. The square root of b to the 8th is b to the 4th. Half the exponent is 4. Square root of c to the 10th, half of that is 5. And then we have the square root of 2a, b. Now multiply. Negative 2 times 5 is negative 10. A, b to the 4th, c to the 5th, the square root of 2a. All right, so that's it. We'll practice more tomorrow. Everybody have a good day and a good night.